Here we have an example where they're asking us to use 6 subintervals to estimate the area between the curve and the x-axis for this given equation right here on this specific x interval. And they're asking us to do this as a left-hand sum, a right-hand sum, a midpoint sum, an upper sum, and a lower sum. So all of our different options for how we could do what is better known as just Riemann sums. This specific video, I'm only going to focus in on the left-hand sum, and then I'll cover right-hand sum, midpoint sum, upper sum, lower sum in subsequent videos. But the process is almost identical for all of them. There's just one move when we select our evaluation point that's going to change up how we do business here. So when you're doing this, the nice part about a problem like this is you don't actually care what the graph looks like. All we want to do first and foremost is just start off by drawing ourselves a little number line here based upon this x interval. So I'm starting at 1 and I'm heading out to 3. From there, we're going to need to split this up into 6 subintervals. And we're going to do that by finding what we call our delta x, the change in x. You can find your delta x, it's always the max of your interval minus the min divided by the number of intervals. So for this specific problem, our max would be 3 minus our min, which is 1, and then they wanted 6 subintervals, so over 6. So out of there you get 2 over 6, which is better known as 1/3. Once you have your delta x, now you're going to go up and you're going to mark your intervals on your number line. So starting at 1 and moving over 1/3. So moving over 1/3, that's going to get me to 4/3, and then we're going to be at 5/3. We're just adding a third every time. We'd be at 6/3, which is also known as 2. Then we'll be at 7/3, then 8/3, and then 9/3, which is better known as 3. After I mark that, I check to make sure that I've got the right number of subintervals. I come through and I say, okay, there's area 1, there's area 2, there's area 3, there's area 4, there's area 5, and there's area 6. So I definitely have the 6 subintervals that we're looking for. And the next part of this I just refer to as the assembly line process. So we're going to need to come up with an area formula for each of these little subsections here. So area 1, area 2, area 3, oops. We don't need to do area 3 twice. Area 4, area 5, and then area 6. We are doing the areas of rectangles, right? So that's kind of the key here, is that this is going to be using rectangles. So the area of a rectangle formula is base times height. That's going to be what we're doing for all of these. The base in these situations is going to be the same because what we're looking at here is a constant 1/3. So 1/3 is going across all of these. That's our delta x, that's our base. So the base on all of these is delta x, delta x, delta x, delta x, delta x, delta x. The height for each of these, the height comes from the y value. It's the function value at that specific point. So what I do is I come through and I say f of, again, assembly line process, f of, and then equals. So right now, really, all of these left-hand, right-hand, midpoint, upper, lower sums, everything up to this point on all of them will look exactly the same. Nothing is going to change at this point. The only thing that changes for us right now is finding these evaluation points. What are we going to plug into our equation? Well, in this situation, we are talking about a left-hand sum specifically. So on every interval, you've got 2 options. You've got a left endpoint and a right endpoint. So if we're looking at A1, we've got a choice, the left endpoint or the right endpoint. We want the left endpoint, so we choose 1. Then we move down the road. And so on A2, this is now my left endpoint and my right endpoint. I want the left endpoint, so I'm looking at 4/3. Go on to A3, same game. This would be the left side of A3, this would be the right side. We want the left endpoint, so we would choose 5/3. We keep going down the list. Looking at A4, we've got a left, we've got a right. We want the left, so we would plug in 2. Then from there, A5, same game. We've got a left side of A5 and we've got the right side of A5. We want the left side, so we would choose 7/3. And then on our finer interval, we've got the left side and we've got the right side. Again, we're looking for the left endpoint, so then we would plug in 8/3. So that is the key difference. What's in orange there, those evaluation points. Depending upon which version of this problem you're being asked to do, will change which points you want to select. From here, it's really just a calculation game at this point. We're plugging all this stuff into our calculator. So delta x on all of these is 1/3, 1/3, 1/3, 1/3, 1/3. Now to find our y values, we are going to take these evaluation points and we are going to plug them back into this original equation. So we are going to go ahead and we are going to plug 1 into that equation. Plugging 1 in, you can do that on your calculator, do it by hand, whatever the requirements are, but plugging 1 in would get us 1. On the next one, we plug 4/3 into that same equation. Plugging in 4/3 is going to give us this lovely number, 52/27. Then we keep working our way down the line. Plugging 5/3 in would get us 59/27. Plugging 2 into that equation would get us 2 out of there. Plugging in 7/3 to that equation would get us out 43/27. And then plugging 8/3 back into that original equation is going to get us 32/27. So as if that wasn't fun enough, that's just getting us our heights. And now to get our full area, we need to multiply all of that stuff together. So we get 1 times 1/3 gets us 1/3. 1/3 times 52/27 gets us 52/81. Then multiplying 1/3 by 59/27 gets us 59/81. 1/3 times 2 gets us 2/3. 1/3 times 43/27 gets us 43/81. And then the last one here, 1/3 times 32/27 is going to get us 32/81. So that is the area of all of our different rectangles. And now to get our approximation, our estimate for that area, our total area would be approximated by taking all of these values here and you're just going to add them. So we add all of those values up. Again, pop that into your calculator, get out whatever your calculator can give you, or do it by hand if you're unlucky enough to have to do it that way. But in the end, we're going to get out of here 89/27. So our left-hand estimate for what the area between the curve and the x-axis is for this specific equation would give us 89/27. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.